In Module 3, Section 5, we will discuss formulas and we will continue to discuss problem solving. A formula is an equation that states a known relationship among multiple quantities. That is to say, a formula will have more than one variable in it. You see listed below a few sample formulas that may be useful as you go throughout this course and specifically as you go throughout this section. Let's start by trying to substitute the given values into the given formula and solve for the unknown variable. If necessary, round to one decimal place. In the place of pi, you want to use the approximation 3.14. So we are given a formula, C equals 2 pi r, where C equals 44. This is the formula that represents the circumference of a circle, the outer edge, perimeter if you want to think of it that way, although that word doesn't really apply to a circle, but the measurement of the outer edge of a circle. So let's take the information we know and plug it into the formula, just like we were evaluating an expression. So in place of C, we write 44. So 44 equals 2. In place of pi, we were told in the problem to use the approximation 3.14. So 2 times 3.14 times r. R is the only variable that we do not have a value for. That's what we're trying to find. So we start by simplifying the right-hand side. We have 44 equals, when we multiply 2 times 3.14, we have 6.28 times r is 6.28r. The last step to solve for r in this problem would be to divide both sides by 6.28. When we do so, the 6.28s on the right-hand side cancel. And on the left-hand side, we need to divide 44 by 6.28. And that will give us a never-ending decimal. We would have 70.063, and that continues forever, equals r. So if we go back to the information in the problem, it says, if necessary, round to one decimal place. Now remember, when we are rounding, we find that one decimal place, and this problem will be the tenths place. We look at the number after the tenths place and decide if we're going to round it up or keep it the same. That's what the down arrow represents. Because 6 is 5 or higher, we'll round the underlined place up, so it rounds to 70.1, and every digit after that first decimal place will be deleted. So 70.1 equals r. Sometimes it is necessary to rewrite a formula so that it is solved for one of the variables that are involved. This is especially true in chemistry or physics, but it could also be true in your daily life if you're making a budget. You have many variables, many unknown expenditures or incomes. So to solve a formula or an equation for a specified variable, we're actually going to use the same steps that we would use if we were solving a linear equation for one variable. The only difference is we treat the specified variable as the only variable in the equation. So if you don't remember how to solve a linear equation, here are the steps again, except now we're going to use these steps in terms of getting one variable isolated in terms of another variable. So I would recommend that you pause this video to write these steps or print this slide, because this will be useful information, especially for the next few examples and the homework problems. For this example, let's solve the formula for the variable h. We have f equals 4gh. Now what I'm going to do is rewrite this problem so that we can see the operations between each variable. So f equals 4 times g times h. To solve for h, we need to essentially move the f and g from the right side to the left side. In order to do that, we want to use the opposite operation so that we can cancel or move our variables and numbers from one side of the equation to the other. So because we are multiplying 4 and g and h together, the opposite operation would be division. So we divide by 4 times g. We divide by everything that we're multiplying that needs to be moved to the other side of the equation. We're going to do that on both sides, 4 times g. So on the right-hand side, we have a common factor of 4 in the numerator and denominator. Those can cancel. We have a common factor of g, and although that's a variable, those can cancel. And on the right-hand side, we're left with nothing but h. So h equals, on the left-hand side, we have f over 4 times g, or just 4g. F has nothing in common with 4 or g, so this would be the simplified solution. We have solved the formula for the variable h, and it is written in terms of the other variables in the formula. Let's try another example. Let's solve 4x minus 7y equals 11 for y. So we're trying to get y by itself. Essentially, at the end, we want y equals something. Remember the steps that we used when we were trying to solve an equation in just one variable. We always tried to simplify each side of the equation, and if we look, we have no like terms on the left side, no like terms on the right side. Once we simplified both sides, we added or subtracted terms in order to move all of the variables that we wanted or that we desired to the left side, all of the undesired variables or quantities to the right side. In this case, that's what we're going to do with the 4x. Because 4x is not being multiplied by the 7y, it wouldn't make sense to divide. We need to subtract instead. So we subtract 4x from each side of the equation. Now when we do so, the opposite 4x's cancel, and we're left with negative 7y equals, on the right-hand side of the equation, we have an 11 and we have a minus 4x. We cannot combine those together. 11 and 4x are not like terms, so we write those beside one another. 11 minus 4x. So we've succeeded in moving the x's to the right-hand side. Now we need to isolate 7, and we will do so by dividing both sides by negative 7. Negative 7 divided by negative 7, that cancels. We're left with y equals. There are ways we could possibly make the right-hand side look better, but we can go ahead and leave it in this form. 11 minus 4x, all divided by negative 7. Let's try another example where we will need to use formulas in order to solve for an unknown quantity. A bullet train set a new world record for train speed at 554 kilometers per hour during a manned test run on the test line in April 1999. The test line is 42.3 kilometers long. How many minutes will a test run on the test line last at this record-setting speed? Now, one formula we will need to use to solve this problem, as well as many problems throughout all of developmental mathematics and college algebra, as you go further, even more problems than that, is the formula distance, d, equals rate times time. Now, the r in this formula can stand for many things. Typically, it will be used to represent speed. Let's take the information from the problem and try to plug it into this formula. First, let's determine what the unknown amount, the unknown quantity. Go to the last sentence and we find how many minutes. And so our unknown quantity is going to be minutes. It's going to be time. We will not have a value to plug in for t. We continue to go through the problem to find other useful information. We have a distance, 42.3 kilometers. Kilometers measure distance. We also have a speed, 554 kilometers per hour. We're going to plug the distance, 42.3 kilometers, in for d. We're going to substitute 554 kilometers per hour in place of r. We will solve for t. So we divide both sides by 554. On the right side, the 554s cancel. Now when we put this value in the calculator, we put in 42.3 divided by 554, and we get a fairly horrible looking decimal. 0.076353, and that continues forever, and that equals t. Now let's talk about what unit t actually represents at this point in time. If we look at the boxed values, we had a boxed value distance of 42.3 kilometers. We also had a boxed value speed of 554 kilometers per hour. As we divided, what we've actually found is the number of hours that it took for a test run on the test line. But if you look at the underlined piece of information in the last sentence, we actually want how many minutes. We need to change this number of hours to a number of minutes. And we do so by multiplying our horrible decimal by 60. So we're going to take this value that you've either written down or kept in the calculator and multiply by 60. Now we don't need to do this on both sides of the equation, just to the value we found, because we're converting it from hours to minutes, because there are 60 minutes in 1 hour. So we take the value that we found times 60, and that equals 4. Let's go ahead and round to 2 decimal places, 4.58 minutes. If you had a problem like this, and you should have something similar to this in your homework, you will be told how to round, whether it's to the nearest whole minute, 1 decimal place, 2 decimal places, or so on. The last example we will see involves the perimeter of a triangle and the perimeter of a square. Now, in case you don't remember, the perimeter is the total length of all of the sides of a particular shape. So it's the sum of all of the side lengths of a shape. The perimeter of an equilateral triangle is 3 inches more than the perimeter of a square, and the side of the triangle is 4 inches longer than the side of the square. Find the side of the triangle. And a hint is given: an equilateral triangle has 3 sides the same length. So before we start working this problem, I'm going to draw, as best as my horrible artistic abilities will allow, an equilateral triangle and a square. Now we are told that the side of a triangle is 4 inches longer than the side of the square. Let's just make up a variable for the side of the square. Why don't we call it A? And so a square has equal lengths for each side. And so if one side is A, all of the sides are A. And we are told in the problem that the length of the side of the triangle is 4 inches longer. If it's 4 inches longer, we should add 4 to each length of the square to find the length of the side of the triangle. So let's call every side of the triangle A plus 4. We're taking that side of the square and adding 4. And because we have an equilateral triangle, all of the sides should have the same length. Now that we have a couple of pictures drawn, one of the square and one of the triangle, let's write an equation that represents the perimeter. The perimeter of the triangle, since it has 3 sides, is 3 times its side length, 3 times A plus 4. The perimeter of the square is 4 times its side length, so 4 times A. Now if we go back to the information given in the problem, it says the perimeter of the triangle is 3 inches more than the perimeter of the square. So what we have on the left side is the perimeter of the triangle, using our keywords, is equals 3 inches more means addition, 3 inches more than the perimeter of the square. Now we have an equation that can be solved. We start by distributing the 3 to both pieces inside parentheses. It gives us 3a plus 3 times 4 is 12 equals 3 plus 4a. Now we need to move all of our variables to one side of the equation, all of our numbers to the other side of the equation. So we can subtract 4a from each side. The 4a's are opposite, so those will cancel. We're left with 3 equals 3a minus 4a is negative 1a plus 12. Now we can subtract 12 from each side. The opposite 12's cancel. And let's write what remains on the next slide. So we'll be left with negative 1a on the left-hand side. 3 minus 12 on the right-hand side is negative 9. We divide each side by negative 1. The negative 1's cancel on the left side, and we have a equals 9. Now remember, a, let's go back to our drawing. A represented the side length of the square. If we go through and read the problem to make sure we've actually answered what's being asked, we're told to find the side of the triangle. Well, we found the side of the square, and that was A. We were told the side of the triangle was 4 more. So the side of the triangle would be 9 plus 4, or 13. Just like in previous sections, the problems may not be exactly the same when we deal with problem solving and word problems. Do the best you can. Make sure to be patient and keep up with your signs.